At the 2026 FIFA World Cup, the stadium hosting the most matches features a retractable roof so massive it weighs roughly the same as a fully loaded cruise ship fleet. During construction in 2006, engineers faced an almost impossible challenge, designing a 1,500-ton movable roof that could open and close smoothly on a structure with no traditional supporting walls or internal pillars. At the time, it was the largest stadium in the world, built with record-breaking unsupported steel arches. But there was a critical problem. The entire roof system sat on a slope of up to 24 degrees, meaning moving something that heavy wasn't just difficult, it bordered on physically unworkable, like trying to slide a fully loaded cargo ship across a tilted deck in the middle of the ocean. Dozens of engineering teams tested different mechanical solutions, but every attempt failed until the breakthrough came from a 150-year-old idea created by a man better known for building the most famous tower on Earth than for anything to do with stadiums. That solution now powers one of the most iconic sports venues in the world, AT&T Stadium in Arlington, Texas. Spanning over 3 million square feet with a seating capacity of up to 80,000, its interior volume is so vast that the Statue of Liberty could stand beneath its roof without even touching it, and you could stack every floor of the Empire State Building inside. The structure is held up by two colossal 393-meter steel arches with no internal pillars, supporting a 1,500-ton retractable roof and a suspended LED screen weighing around 544,000 kilograms, roughly the same as 80 fully grown African elephants hanging in midair above the field. But the real engineering breakthrough came from the past. In 1875, during railway construction in Portugal, civil engineer Gustave Eiffel, the same man behind the Eiffel Tower, developed a parabolic arch system reinforced with triangular trusses. These geometric shapes are so stable, they maintain their form under extreme pressure without bending or collapsing, the same way a triangle in a roof frame holds its shape even as the weight of snow piles up above it. This principle was scaled up for the stadium, where the massive arches transfer their forces into 4 concrete anchor blocks, each requiring as much concrete as an entire city block of residential buildings. Because steel expands under Texas heat, expansion joints were added throughout the structure so it can safely breathe with the seasons. For the retractable roof, engineers rejected traditional winch systems since lifting 1,500 tons would require machinery nearly as heavy as the roof itself, like needing a second truck just to carry the first one. Instead, they adopted a rack and pinion mechanism, the same principle used in 19th century mountain cog railways to push trains up steep inclines. Over 100 synchronized motors move both roof panels in perfect balance so the weight stays evenly distributed across the arches, allowing the roof to fully open in about 12 minutes. Inside, cooling a space this size, roughly equivalent to stacking 30,000 apartments under one roof, required an industrial 11,000-ton chiller system that pushes cold air through massive overhead ducts. Above the field hangs a gigantic 360-degree LED screen that feels less like a scoreboard and more like a floating digital sky, visible from every single seat in the stadium. Even the enormous glass doors at each end zone, each weighing tens of thousands of kilograms, operate through the same synchronized mechanical system and take nearly 18 minutes to fully open or close, moving slower than a person walks, yet carrying more weight than a fleet of semi-trucks. Beneath it all lies a flexible field system designed for multiple sports, but for FIFA requirements, natural grass must be used, so the surface is grown off-site, carefully maintained, and transported in refrigerated sections before every major match, like delivering a living carpet across the city. In the end, this stadium is not just a sports venue. It is proof that the biggest breakthroughs in modern engineering often trace back to a single old idea, applied by the right mind at the right scale, turning what once seemed physically impossible into a working reality on the world stage.